Welcome to Econ 102, where economist Noah Smith and I make sense of what's happening in the news, technology, business, and beyond through the lens of economics. Let's jump right in.
This week, we're airing a live conversation between Noah Smith and Sam D'Amico, founder and CEO of Impulse Labs, about China's dominance in modern manufacturing. Beyond subsidies and cheap loans, Sam explains how Chinese companies have quietly mastered what he calls the electric tech stack, a powerful suite of technologies driving their lead in industries from EVs to robotics. This was taped in front of a live audience at Edge Esmeralda.
Here's a question. What do you call a pig with 3 eyes?
No idea.
Pig.
Oh, there we go.
Oh, good. Whew. That's my contribution to stand-up right there.
Mid.
Yeah, fair. All right, so today we're going to talk about manufacturing. You may have noticed that China makes a lot of stuff, and we don't make nearly as much stuff. And what are some examples of things that China makes a lot of that we don't make a lot of?
Soon, battery-powered stoves.
Well, I would say that's something that we make that they don't make a lot of.
Well,
but okay. So basically, China's out manufacturing us along a variety of fronts, and everyone's kind of worried about this, and everyone is like, concerned about what to do about this. Sam has really come up with the first cogent answers that I've heard of to this question, and so basically, Sam runs a company called Impulse that makes battery-powered appliances and stuff like that. So Sam, why don't you introduce Impulse and explain what they do?
yeah, so there's a stove. I'm not sure where it is. It's over there, or over there. So you can go try it out, but basically it's the most powerful stove ever made. It's like 3 times more powerful than other induction stoves. And you can set and hold an exact temperature. But that's not all. It has a battery in it. And so what the battery does is it boosts the power way above what the wall would supply. So you can plug it in on any outlet, run on 240, run on 120, it doesn't really matter. But it also is the beginning of being able to seed the grid with a decentralized energy storage network, because every appliance will get a battery. And if you put a battery in every appliance, you've essentially controlled the grid, because the edges of the grid all have batteries now that are software defined. And so we see this as a really exciting opportunity, basically, to do a permissionless upgrade to the grid in a more resilient way. It's going to be super exciting. But the topic of this talk is not my startup.
That's right, but they have to know what it is before they understand why you're a person who's qualified to talk
and so
about
this is what I was going to say is exactly. We're basically using the electrification stack. I think basically, if you think of what the most modern devices today are, and what China is specifically better than us at, it's stuff like drones, electric cars. What's the other one?
Drones, electric cars,
smartphones and consumer electronics, and
smartphones, consumer electronics,
and
everything.
robots.
And robots. That is right. That's right. Robots,
including the one over there.
Right. So to reiterate and simplify here, Sam is doing a consumer electronics manufacturing company in America. That is a really, really hard thing to do. That is the kind of thing where normally people would say, no, we will never do that. China will do that, and we'll simply import whatever it is from China. They are the masters of consumer electronics manufacturing. However, that's a little, that's not going to cut the mustard anymore, because a couple days ago, Ukraine shipped a whole bunch of shipping containers full of little toy battery-powered drones into Russia. And then suddenly the little battery-powered drones popped out of their little shipping containers and blew up a whole bunch of nuclear bombers 4,000 kilometers into Russia. And so the world has changed, and battery-powered, like consumer electronics stuff, is now suddenly the most powerful tech, military tech in the world. And so the question is, how do we get what they have? How do we manufacture that kind of stuff? Otherwise, we're a little bit sunk as a major power, at least. And so that's what I'm here to ask Sam about. So Sam, basically, what's your short read on why we are bad at manufacturing consumer electronics and China is good at that?
Yeah. So, and maybe I can start with the example of so I've manufactured a lot of things in China over the years. I actually had a Chinese residence permit at one point. So I visited manufacturers in Shenzhen, in other parts of China, been done all the tourist stuff too. So if you want China tips, let me know. But basically, been to, but yeah. So basically, what you see, and I've actually done hardware stuff in the United States as well. The biggest problem in the US is like, if you want to build something here, you don't get the Lego set to actually build it in a simplified sense. And your engineers are not necessarily co-located with anyone who actually has the means of building stuff.
So what that means is that in China, the engineers live near the factory. In America, the engineers live far away from the factory.
Yeah, and I think I was telling you this in the car. Is basically the engineers in the United States have moved up the value chain and are working for major corporations like Google and OpenAI and all this other stuff. They're going to be, they now live in NIMBY cities with NIMBY policies, basically. And do you think those cities are affordable for someone who wants to work in manufacturing and make $35 an hour? Or something like that? The answer is these people literally do not live in the same place.
Well, nothing's stopping, tech nerds, nothing's stopping, smart, highly paid engineers from going and living near the kind of people who work in factories and going and living near those factories. They may just not necessarily want to.
Yeah, and I think we've essentially, in the United States, we've essentially segregated, in some sense, the like intellectual laptop class or whatever people want to call
Us.
Yeah. Us from the remaining factories that still do stuff. And part of this actually is how the factories or how manufactured goods in the United States kind of go together. And actually, a lot of this is kind of the old way of doing things has like, pre-software is we haven't transitioned past that.
Right. Okay. So first, let's think about if you wanted to make stuff well, like they do in China. If you want to make electronic stuff effectively, efficiently, you need your engineers to live next to your workers so that they can do what?
Yeah, so basically when you build a product, you're not just building the product, you're building the process to produce the product. I think Elon had some quotes like the factory is the product. Effectively, you need to build the machine that makes the machine. And to build the machine to make the machine, you got to be there to do it. You can't just it's not like committing your code to GitHub. Like it's you have to actually go be there. And additionally, when you go and design stuff, like I'm figuring out how to design some part of the stove or whatever. I have to know what resources and parts and supply chain exist at the actual factory site for me to know how to design it. Because you could go design something in you could design something in a bubble where you're like, I have to do everything from scratch. And maybe if you've got enough money and resources, you can. But in reality, you want to basically buy stuff that's like 80 to 90% of what you want made by someone that knows how to make it. And for that, you need those supply chain connections. You need to be kind of plugged in to...
So in China, you can, suppose you want to make like battery-powered stoves and you're in China. There's a factory in China that knows how to make... They don't know how to make that because that's never been made
They know how to
before.
make stoves, though.
They know how to make stoves. There's people who know how to make stoves. There's people who know how to make battery-powered this and that. Maybe leaf blowers. I don't know. I made that up. So you go by their factory and say, hey, guys, can you make us a few of these? You show them the thing. They're like, okay, we'll try that. And then your engineers who designed the product work with their engineers who know how to set up the factory process, set up the machines. And those together work it out and make it maybe not at a large batch, but certainly at a small batch that allows you to iterate very quickly and get better and better versions of this thing.
Yeah, exactly. And those feedback loops are really important because it's like, I think one thing is, you end up building and throwing away, I think we built like 200 or 300 units before we're like that are not shippable product, before we even got to the point of like, yeah, this thing's really good and we've worked out all the bugs and like we've reliability tested everything and all this other stuff. And that was like, you could call it 3 discrete phases of the company, like where we were actually talking to the factory and building those samples, but it actually ended up being like 4 or 5 just because of like, we kind of stopped it partway through and then we're like, let's fix this. And then we updated. So you end up iterating a lot and you have to iterate in a way where we send our engineers to the factory to go work with the factory workers.
Right, because the iteration can't just be mailing designs and photos of like what you're doing and sending emails. The iteration has to be you go down there and you see how the thing actually works.
And you realize they're plugging in the cable backwards.
Yes, and it's physical. Manufacturing works different than software, and we're not, all of our smart people have been optimized for the software sort of production process, and we have relatively few smart people who remember how to do the manufacturing production process.
Yeah, and I think that the big thing is also like the difference here is like we've essentially figured out clean interfaces for software. You could argue we've done this for chip design as well. Like NVIDIA is a fabless company, like they're not next to TSMC to make this happen.
It's a kind of hardware manufacturing whose production process sort of works like software. You just you make a design, you mail it, it comes back.
Yeah, exactly. But
you commit to GitHub basically.
But basically, when you're making something like a consumer electronics device or a drone or an EV, you end up having to kind of work down the stack, not just on not just like the total top level vehicle. And this is the big mindset shift that actually makes Tesla make better cars than like Ford. Is Ford goes and buys off the shelf parts from like German and Canadian parts manufacturers kind of in their existing ecosystem. And if that part isn't available, it's like very painful and long lead time to customize. That's why like no other vehicles had large displays on them until very recently, because Tesla had to actually go to a consumer electronics supplier to go build that large tablet-like screen that goes on the Model 3 and the Model S. Like that didn't exist. And so Tesla actually had to go and source stuff through a more consumer electronics supply chain where they were not buying off the shelf parts, but actually designing stuff down the stack through the sub-suppliers as well. And you can do that if you think about it like a consumer electronics device, and you think about it like you've got access to an ecosystem that's willing to let you customize, like exists in China.
So all right. So let's go to a broader point here. In the old days, which is to say the 90s or even the early 2000s, different types of manufactured products were extremely different. If you wanted to make cars or the engines that went in cars, or if you wanted to make aircraft or the engines that went in aircraft, or if you wanted to make TVs, or if you wanted to make all this other stuff, it was fragmented. It was different, very different production processes for different types of things. And now a new thing has happened to our world, which is that we have a new tech stack, a new set of technology modules, a new set of basic standardized components that can be put together in a variety of ways to make physical products that replace so many of the things around us. For example, you can, with stuff similar to what you'd put in a phone, plus like a motor, you can make a car. A car is a phone. You can make a drone, which will substitute for like, bombers and fighter bombers, whatever. Like you can make, robots will do various things. You can make a machine tool is basically robot will substitute for that. The robot will simply be a battery, a motor, some various computer chips and power
electronics,
which
and
are
magnets and magnets.
Magnets are in the motor.
Yeah, the motor. Yeah,
the motor. Yeah. So it's basically a battery, a motor, and some chip. I mean, power electronics and some chips, right? Some chips, it's a battery, a motor, and some chips. That's everything. That's a robot.
Software,
that's a drone. And software. Obviously, into software. But that's and an almost fanatical devotion to the Pope. No, that's a different one. Monty Python. Anyway, am I that old? All right.
Yes.
So, anyway, so the point is that this electric tech stack of battery, motor, and chips is basically eating the rest of the world. It's eating the world. And so many of our things, our cars, even our planes, even our, whatever, are being replaced by just things that are fancy ass drones.
Yeah, I said this on another panel once, and I said the tanks will become woke. Because effectively, like every military vehicle is going to become a series hybrid in the next 20 years or so. And when a series hybrid, to define that is like you basically have you're moving with electric motors and you're putting energy into a battery, but you may be charging that battery with like an engine because you need fuel because you may be really long range or something like that. But basically, the tanks will go woke and they'll be higher power and they'll have like 200 kilowatt lasers on them, if not more, for air defense against these drones.
Right.
We'll continue our interview in a moment after a word from our sponsors. When I had Harley Finkelstein, Shopify's president, on the show, he said something that really hit home for me as an entrepreneur.
Shopify, we pray at the altar of small business and entrepreneurship. I do think there's a lot of people out there who have a thing in their life, but for some reason or another, usually because they either think they have no experience or it's too expensive or too complicated, they do not cross the chasm from aspiring entrepreneur to entrepreneur.
Making entrepreneurship more accessible, that's exactly what we're talking about. It's not about having the biggest team or the deepest pockets. It's about having the right tools that level the playing field. And that's exactly what Shopify does for entrepreneurs everywhere. The biggest advantage you can have as an entrepreneur isn't money, it's agility. And that means having systems that move as fast as you do. Shopify's point of sale system is a unified command center that brings together your in-store and online operations across up to 1,000 locations. Your competitive edge comes from making buying from you as effortless as possible. Imagine being able to guarantee that shopping is always convenient. Endless aisle, ship to customer, buy online, pickup in store, all made simpler so customers can shop how they want and staff have the tools to close the sale every time. And let's face it, acquiring new customers is expensive. With Shopify POS, you can keep shoppers coming back with personalized experiences and first-party data that give your marketing team a competitive edge. In fact, it's proven. Based on a report from EY, businesses on Shopify POS see real results, like 22% better total cost of ownership and benefits, equivalent to an 8.9% uplift in sales on average relative to the market set surveyed. As Harley said, the cost of failure has never been lower and the tools have never been better. Turn those what ifs into why nots and keep giving those big dreams the best shot with Shopify. Get all the big stuff for your small business right with Shopify. Sign up for your $1 per month trial and start selling today at shopify.com/momentofzen. Go to shopify.com/momentofzen. Shopify.com/momentofzen. It's an interesting time for business. Tariff and trade policies are dynamic, supply chains squeezed, and cash flow tighter than ever. If your business can't adapt in real time, you're in a world of hurt. You need total visibility, from global shipments to tariff impacts to real-time cash flow. That's NetSuite by Oracle, your AI-powered business management suite, trusted by over 42,000 businesses. NetSuite is the #1 cloud ERP for many reasons. It brings accounting, financial management, inventory, HR into one suite. With one unified business management suite, there's one source of truth, giving you the visibility and control you need to make quick decisions. With real-time forecasting, you're peering into the future with actionable data. And with AI embedded throughout, you can automate a lot of those everyday tasks, letting your team stay strategic. NetSuite helps you know what's stuck, what it's costing you, and how to pivot fast. If I had needed this product, it's what I'd use. It's one system, full control. Tame the chaos with NetSuite. If your revenues are at least in the 7 figures, download the free ebook, Navigating Global Trade, 3 Insights for Leaders, at netsuite.com/102. That's netsuite.com/102.
I want to focus on that word woke because it's a joke, but the point is that right now, Republicans in Congress and the Trump administration are hard at work canceling all EV subsidies and all sort of programs designed to make America build more batteries. After this era where we suddenly started building a whole bunch of battery factories under Biden, those are now being canceled. And then basically the GOP is trying to fight the advent of the electric tech stack for culture war reasons, because they think that electric technologies are a bunch of hippy-dippy bullshit. And that's why when you talk about a tank going electric, you can joke about it being woke, because people have turned this thing that should be about raw power and efficiency and energy and, physical stuff into this discussion about culture wars.
Yeah, and I think like the light bulb thing is actually a good example too from the past. Is we have a new electric tech stack. We have an electric tech stack from the past. That's like the Thomas Edison stack. It's the General Electric stack, the OG General Electric before Jack Welch destroyed it. But basically that's like generators, that's light bulbs, that's like transformers. That's kind of like all the stuff that didn't need transistors to get fully developed. And that includes some parts of the grid as well. And the new one, it's interesting, is like it's LEDs, it's power electronics, it's brushless DC motors versus like AC motors. Like in some sense, we've come with this new technology is so superior to the previous technology that it's able to displace kind of these higher power density fuel based approaches and other things like that. But it is important to know that like this is what China has indexed on as the future tech stack. And they know that the US is underinvesting in it. And they know that they have got this moment of opportunity.
Right. China's not great at building a jet engine. China's like not really yet great at building leading edge semiconductors. China wasn't great at building cars. Like, they couldn't really enter the global car industry very well. But all they have to do to be supreme at manufacturing is replace every single physical thing that exists with a variant of a cell phone.
Yes.
And they're going to do that, and then they will rule the world with that.
And all of those devices will be better.
Yeah, they'll all be better.
Because the difference is this kind of coming wave is entirely software defined. you're able to actually define the physical performance of the device with software.
Right. So, okay, so let's play a little game. I'm going to go through elements of this tech stack, and I'll ask you, how much of this can America make?
Yep.
All right? So let's start with the easy stuff, injection molding.
We do that. I think it's a lot of what we do is like lawn chairs and stuff like that. You know, like things that didn't get outsourced to China, like, and they're large, basically.
Okay.
But like injection molded lenses for mobile phone cameras, hell no.
Okay. So we need better injection molding. Carbon fiber.
We're okay.
Okay, cool. Trailing edge computer chips, like sensors and microcontrollers.
Yeah, we're solid at that.
Cool. Power electronics.
Solid.
We are. Where do we make power electronics now?
I don't know, like Cree in like North Carolina or something. I don't know.
Okay, got it. Electric motors. Should we break that down by the pieces?
Yeah,
of
we got to
motor?
break that down. So it's
Okay.
like pretty much, if you go buy electric motors today, they're pretty much always made in China.
Yes, they're made in China.
Unless there's some EV company.
An electric motor has wire, a stator, rotator, and then the magnets in the rotator.
Yeah. The magnet. Yeah. So there's a couple different ways to construct an electric motor. The one that people talk about when they talk about rare earth metals and conflict minerals and all this other stuff, that's a DC brushless electric motor is the common term for it. But it has a DC permanent magnet motor. Permanent magnet nowadays means neodymium, which means it's a rare earth metal.
How about samarium?
Also, they're not as good.
Okay, so neodymium is the thing.
And
Neodymium,
we've
remember
gotten
that.
better at neodymium permanent magnets over the past even like 10 years. I think like the flux density is higher now.
So something changed. Magnets got hella good. When did they get hella good?
90s.
Why?
I think it was basically like hard drives.
Oh, interesting.
So the hard drive industry needed really strong magnets to make small hard drives. So you could like write and that was like a giant demand for these neodymium
Got
magnets.
it. Okay, but who does China mine all the neodymium out of the ground?
I'm pretty sure that's mined in like a bunch of places. I think the big problem is actually making the powder and like basically turning the mined stuff into a sinterable powder to make the magnets.
Which is what they call refining.
Yeah, or the refining operation.
Why is all refining done in China for neodymium?
So this goes back to why America can't build more generically, and we should actually talk about this. Is like first issue I mentioned, which I mentioned at the very beginning, is like we don't build housing for work for factory work that factory workers can afford near where all the intellectual elite that would actually be able to run basically be able to design the products are. That's the first thing. But the second thing is this goes back to NEPA and various like EPA regulations that were well intentioned against kind of like literal like air and water pollution. And it turns out that like we've kind of decided to say that anything that involves fun chemistry we shouldn't do without a lot of permits.
Why?
Because it used to cause air and water pollution, and that's bad.
But now will it?
It's definitely better because we have way better ways to measure all this stuff. We also have I almost think we should be regulating the pollution outputs, but there's a better option that the market has decided. The market has decided that, you might as well just do it in China because they've got state subsidies to set up a neodymium refinery.
Got it. So to sum up, what happened in the 1970s was if you had any factory that did a bunch of chemical stuff, it would be hella polluting. So we banned that all, and then we outsourced it to China, who was willing to pollute and kill a bunch of people, make people born with like 6 toes.
That sounds cool as hell, man.
That's my friend Jenny. She was born in Beijing with 6 toes.
I'll check my.
11 toes. But she she's down to 10 now. But yeah,
I would have kept it.
Legend. Anyway, but the point is because they grew up near a chemical factory. Eventually it becomes sad. Her dad died of leukemia much later, so it's very sad.
I mean, a good example is like my grandfather died of liver cancer from being exposed from it was like sewage runoff or some sort of, it may have been industrial related, but from one of these military bases that you see ads for at 2 a.m. on CNN or whatever. And there's a huge settlement. So
it sucked.
Yeah, it sucked.
But so actually, this is the Neil Stephenson book Zodiac. If you go look at, even before he wrote that book making fun of like woke college politics, the Big U, he wrote a book called Zodiac, which is basically like a guerrilla environmental activist running around identifying like companies that were dumping toxic crap into the bay and then reporting them.
Yep.
And so like there was a big problem back in the day. And so we got rid of that by basically banning all that stuff and saying you can't do anything anywhere. And then China did it, and China was like, well, we can't have all these people being born with 6 toes. Let's invent cleaner ways to do that. And then China invented cleaner ways to do that. We still don't allow the cleaner ways to do that.
Yes.
So now China wins, even though we could allow that stuff and not have pollution everywhere.
Yeah, like, so I've visited BYD many times, and like their HQ is kind of this awesome place. Like, it kind of, you go there and you're like, okay, this is cooler than like visiting Google. This is like visiting Google if you're like in 2012 and like visiting Google was a cool thing back then. Their cafeteria is
We're so old, we have to clarify
the
that.
BYD VIP cafeteria just absolutely crushes any FANG tech company during FANG's heyday. Like, I'm just not going to say, like, it just like absolutely crushes them. Mogs, as the Gen Z would say.
Mogs.
Yeah. But but what's
We have a secret group of Gen Z people to teach us the slang. They're sitting here anyway to teach us.
They'll argue they're not Gen Z. But the thing is a typical Chinese factory. Like, you go to one of these like super advanced factories or whatever. What is the emissions of that factory? They're usually like, it's trash. It's like an Amazon warehouse. We've legalized Amazon warehouses, but we've like made it really hard to build like electrified products.
Right.
And then also, like, we've essentially psyoped ourselves into, oh, batteries are really polluting. Aren't the batteries polluting? I get asked about this all the time for our products and stuff like that. I'm like, you buy the battery, it stays in the product. It doesn't get thrown out like a day later. Like, it's not like it's burned in fuel or whatever. So
it's like, isn't your gas tank in your car polluting? Well, you don't throw it in the river.
But exactly. So the point though is like, this stuff is not polluting anymore, but there's some upstream dependencies that make it really, really, really hard to permit a factory in the United States. And so you look at, I think Elon is, I got to bring him up again, because Elon is the only guy who has figured this out, and he's done this multiple times. And I've been spending probably way too much of my waking hours trying to reverse engineer how the hell is this actually happening? Because it doesn't make any sense.
Let's clarify.
Yeah.
There have been 2 large, scaled up, high tech, cutting edge manufacturing companies built in the United States in the last half century. Let's say the last 30 years.
Last 20 years. Let's say last 20 years.
Okay.
Yeah.
They have been both built by one guy.
One dude.
And, kind of a wacky dude, honestly. What is that guy's secret sauce? If there were only one, if it was just Tesla, we'd be like, okay, fine, he got lucky, one guy out of everybody.
Emerald Mine.
He did, yeah, Emerald Mine. I don't know, but like, that wasn't real. But
it's not real. Yeah.
But then, no, but the question is, how did he do it twice? Then he goes and builds the best rocket company in the world. He builds the best electric car company in the world. Then he builds the best rocket company in the world. This one guy, what's his secret sauce?
And you could argue SpaceX actually did it like multiple times. Like Falcon 1 working at all, insane. Falcon 9 working at all, insane. Starlink working at all, insane. Falcon 9 recovery working at all, insane.
Okay,
Starship
many things are insane. How did he do it?
Okay, so
what's his sauce?
So I like to fixate on stuff. Many of you may figure this out. And this is one thing I've fixated on for a while because it's strange, right? So let's look at China for a second. China, maybe they've got their Elon. They might have their Elon. He's who's the BYD guy? Like, I'm trying to remember the guy's name.
Let's not butcher Chinese names. All right.
Yeah, we're not butchering Chinese names today. But so the BYD chairman is probably like the closest example of this. But like, there's the Unitree founder, there's the DJI founder, there are so many of these people, almost as numerous as like Silicon Valley legends, right? But why is like in some sense that's kind of their equivalent. Like, there's all of these amazing software founders in the Bay Area. China's got that for hardware, and it turns out that like they don't have to be exactly Elon Musk. They can be like 70% of him or less, and they can get away with it because the society, the industrial policy, the permission structures around building stuff, the capital markets, state debt facilities, et cetera, are all there to kind of encourage all of this.
Right. Okay. So basically, in the United States, let's say there's 20 huge barriers that we put up against building factories for anything. Okay?
So only one crazy goblin can do it.
One crazy goblin. One crazy goblin managed to be good enough at all 20 things and just overcome all 20 hurdles.
He mogs.
But if we took away 5 of those barriers, maybe we'd have 7 or 8 other not quite so crazy goblins who'd be able to overcome 15 of the 20 but couldn't quite get to all 20.
Yeah, I think
so we could get a whole bunch of near Elons to build a whole bunch more great manufacturing companies in America if we just took away a few of those barriers.
Yeah, and I think another example is look, Jeff Bezos is a great founder, right? And if he had if it was almost impossible for him to actually build a rocket company, Blue Origin's operational now-ish, but that cost billions of dollars of his own money and all this other stuff to actually get on this level. And that's with someone who's already clearly proven that they can operate a major international mega corporation at the top tier, and he had trouble with this stuff. So it's understanding that is crazy. So then I like to use this one example about this when I talk to people about it, and it involves tents. Have you guys been under a tent for graduation, or you've seen those tents that cover turf fields or in winter or whatever?
Big
tents. Maybe the abundance movement will bring Elon back into their big tent, after he crashed out with Trump this week. But we'll find out. I like to slip jokes in there. So there was a problem. So Elon's in his production hell for Model 3. They build a highly automated, I think he called it a alien dreadnought. He was like, yeah, we got the alien dreadnought of factories. We built the alien dreadnought. It's so cool, man. And so he builds his alien dreadnought, and then it sucks at producing cars. And the problem, though, is he has to sell those cars because, Tesla hardware companies are really, really hard to run from a cash flow perspective. This is, again, something that China has a lot of interesting financial products and state capitalism that they can help support businesses.
This is my thing.
Yeah.
I'm looking into the financing of manufacturing and how we can get that.
And Elon got this with, thanks Obama and all this other stuff, and also buying a cheap factory.
But what do you do with the tents?
So what do you do with the tents? So basically, he couldn't reconfigure his factory because he'd need to build a new building to keep production running on the existing line. And he then would, but then the problem is, where is his factory? Fremont, California. So Fremont is Fremont is East Bay Area. It's full of NIMBYs. It's probably the best way to describe it. Also, Elon is not necessarily the most popular person among the local homeowners associations or anything like that.
Fremont NIMBY to Ranch 99.
Yeah, I did not know that Fremont ran. They
NIMBY to 99.
So Elon got incredibly lucky with that factory, which is GM went bankrupt, or GM was in deep trouble in the 2008 recession. They had to sell a lot of their assets.
That factory is called NUMMI. It was a joint factory between GM and Toyota that was really good at making cars.
And so it was basically it's how the U.S. learned how to catch up with Japan on the manufacturing side. Professing
Okay, so anyway, there was this factory. Elon got it
for really cheap. Thanks Obama.
But the point was that it was already permitted.
It was already permitted.
So he didn't have to build a new one.
For paint booth, metal treatment, all this other stuff that is currently pretty much illegal to do in California.
Right.
If you want to paint cars in California and you're not Joe's Auto Shop, but you're cool, we're making if we're making
Stanford Solar Car. I don't know.
No. That's one. You can paint one car just fine. You can run Joe's Auto Shop because we need to do collision repair and
okay,
repair
but you can't
broken
paint cars as a business.
You can't paint cars as a business because, well, you're spraying plastic in the air basically.
Right.
We'll continue our interview in a moment after a word from our sponsors. Every time I hop on the 101 freeway in SF, I look up at the various tech billboards and think, damn, turpentine should definitely be up there. And I bet I'm not alone. In a world of endless scrolling and ad blockers, sometimes the most powerful way to reach people is in the real world. That's where AdQuick comes in. The easiest way to book out-of-home ads, like billboards, vehicle wraps, and airport displays. The same way you would order an Uber. Started by Instacart alums, AdQuick was born from their own personal struggles to book and measure ad success. AdQuick's audience targeting, campaign management, and analytics bring the precision and efficiency of digital to the real world. Ready to get your brand the attention it deserves? Visit adquick.com today to start reaching your customers in the real world. Again, that's adquick.com.
Okay, back on track.
So he couldn't change this factory.
All right, suppose I am dictator of America tomorrow, and my first degree will be that everyone should respect pet rabbits and feed them. But then, no, my second decree will be that we're going to jumpstart American manufacturing. What are we going to do? What do I do day one? Where do I start?
I would invest in America's tent supply because that's what Elon did. He basically put a tent in the parking lot and moved a bunch of the factory equipment there because he did not need to pull permits for the factory to do the rearrangement of all of his equipment. But this actually gets to what you need to do, which is it's housing and land use. You need to basically largely liberalize land use regulations for advanced manufacturing. You need to treat that just like it's an Amazon warehouse. And if you can do that, because we allow Amazon warehouses in residential areas because people want their cheap stuff. And we figured out, like, it turns out that things that are easy to do are easy to do because people ask for it a lot. So like Amazon warehouses, appliance installations are much easier to install than home batteries because your appliances break all the time. And if you have to wait like 6 months to get a new fridge, like that's not acceptable. And so it turns out that there are certain things we've already fast tracked in our society. And it's like, look at what those have as their capabilities and then make sure that manufacturing gets the same treatment.
Got it. That's a great answer. So should we create special economic zones where suppliers can cluster? Because you talked about this thing in China where they have this thick market of suppliers.
Yep.
In other words, if you're in China, you're trying to make a doohickey, you need a camera in it. You walk down and you're in Shenzhen.
Yeah,
right?
Then I go to Zhongshan and talk to Sunny.
You walk down the street and you go to the camera guys who know how to make.
You could literally go. So in the heyday, it still exists.
Okay, but let's. But if you need like a screen, you go to the screen people. If you need
and they're all in the same building. They're all in the same building.
Should we have a special economic zone like that in America where all the suppliers go, where you can have both factory workers and engineers all live alongside each other?
So the example.
And should it be Austin, Texas?
So Austin is where Elon's attempting to do this right now. Actually, and I think it may work, but
Austin will allow you to build lots of things.
Yeah,
and like the area south of Austin,
and they have a chip industry. They've got AMD, they've got TI,
nerds. I notice lots of people from Austin here. Nerds love to live in Austin, and yet
you can go to an axe throwing bar.
You can go to an axe throwing bar. It's a great place for people. You
can get white people tacos.
You can, but then anyone who'd work in a factory can live cheaply.
Yes.
In the south suburbs of Austin in a safe, cheap, clean area. Yeah. So that's why I thought maybe Austin could be our Shenzhen.
Yeah, and I think there's a strong attempt at that. I actually think that there's this interesting opportunity where if you look at where Tesla's already building Megapack and Powerwall, they're doing it in Lathrop, which is kind of like closer to the Central Valley near Stockton in California.
Oh yeah.
And it's close enough to the engineers, but like where are the engineers today? And you go look at the past for Prolog. So like Hong Kong, Shenzhen is essentially an outgrowth of Hong Kong for manufacturing. Where were all of the brands that were selling these goods back in the day? They were based in Hong Kong, and their factories were in Shenzhen. And we've now kind of forgotten that that's how it used to work. Like these were businesses based in Hong Kong with their manufacturing arms. And you can imagine some places like San Francisco that maybe are way too expensive, and like Hong Kong, honestly, could find satellite locations where yes, you could build a manufacturing special economic zone, a short drive away.
Okay, so where can we do that?
I mean, the California Forever idea is not a terrible one. That's not a terrible one. I mean, until that exists, Stockton and Lathrop aren't that bad. You just have to cross over the mountains a bit, because basically where you get to the Central Valley, like essentially you need to get to in the United States.
Can you drive there and back easily in a day and inspect the factory?
Yeah, so I think that's the key thing is like when I've seen this in China where the engineering office is separate from the factory, and it's actually in many cases it is for these larger companies.
How long a drive is it from San Francisco to Lathrop?
Like an hour, 2 hours maybe.
2 hours. So you do a
like
4-hour drive to inspect a factory.
Yeah, and that's about what if I want to go to. Like I think the threshold for far is probably like Giga Nevada, like the Nevada battery factory that Tesla has.
Too far.
That's probably the threshold.
You have to stay overnight.
Yeah, you stay overnight. But like in China, there's like it's very typical to have like your factory location's a 2-hour drive from the engineering office.
Right.
And I think that's probably
and with high-speed rail, you can do that even easier.
Yeah,
Send the engineer out to the place.
Yeah. So.
Got it. Okay, so that's what we do. We look at creating some like regional clusters where it's super easy to build stuff and the engineers can live near the factory workers.
Yeah, and I think Austin is not a bad option here. I think there's probably some interesting opportunities on the East Coast, like Massachusetts area, interestingly enough, for certain things, and then North Carolina, like that kind of like the North Carolina Research Triangle area is probably the other zone, like where Airbus and some of like and some of those
like rally.
Yeah. And there's a lot of really good engineers out there. And then I'm thinking about some other ones. It's like Phoenix area with like chips and stuff like that.
You know that like 6 months after you tell me this, it's going to be a Brookings proposal, right?
Unfortunately.
Anyway, yeah,
Possible.
we
yeah.
want that.
Yeah,
we
no,
want
that's
that.
good.
Brookings is the only think tank that nobody hates.
So basically, what I think needs to happen though is every city, every like superstar city in the United States, needs to think about where their Shenzhen is, because it's not about we need to turn this city into a Shenzhen. We need to look for our Hong Kongs and make the Shenzhen happen.
Got it. Okay, that's a great way to think about it. All right, 2 more questions about policy. Industrial policy. Okay, what industries do we need to spin up quickly that China has that we don't have at all yet? So we know rare earth.
Yeah, I just invested
obviously in
batteries.
but what else?
I just invested in an electric motor company that I helped name.
What's it called?
Western Magnetics Company.
Western Magnetics. That's pretty cool. I like it. All right, so
nominative determinism.
Yeah, right. All right, so electric motors. What about cameras?
Cameras. So I spent way too long mucking with camera modules and like doing testing. My first job out of college was working on the Google Glass camera, one of the more notorious cameras ever made. And so it's interesting that like if you need to build a like custom camera for your product and your product's like a defense item, like let's say I'm like Anduril and I need a special camera for my drone or whatever. I have to follow ITAR. There's no US camera module manufacturer that does this at high volume, like at all. And so maybe I can get a State Department exemption to go use LG or something like that in South Korea. But frankly, this is not something that exists at this point. And unless we had a domestic smartphone industry, there probably wouldn't be ever the demand pull to pull it on short.
Do we need an Inflation Reduction Act or CHIPS Act for smartphones?
I mean, if I
or drones.
So the craziest thing about camera modules is I've been on these lines before. It is ridiculously automated in most cases. Like it's like you buy these like boxes and you can do the lights closed factory thing for like order of magnitude a couple.
That means
$1,000,000.
It's a purely robotic factory.
It's basically like you just get these little like cubes and you connect them together. And you have to put some of them in a clean room, and then and some of them have to go to a really specific clean room. But that's about it.
So if we had an industrial policy for like phones or drones or something, then so basically, it's not quite right to say everything's a phone because the phone doesn't have a motor. It's more right to say that everything's an EV or drone.
Yeah, everything's an EV or drone or robot. Yeah,
that's the electric tech stack that's eating the world. Electricity is eating the world.
Electricity is eating the world.
All right, and then my final answer is like question is back to Impulse. Final answer. Back to Impulse. What the future of give you a little chance to like pump the company here. The future of Impulse, like how will that fit into this future electric ecosystem in America?
Yeah, so I think the first thing is we basically reinvented like the kitchen stove around this new tech stack, and that's like batteries, that's power electronics, that's like phone-like compute. That's also being like neurotic about all the details down to the individual modules versus sourcing off-the-shelf parts. It's making this kind of fully integrated software-defined system. Now, so it's very much like a drone or a robot or something like that than it is like assembled like a stove. So that's the first thing. But then we've actually found really big market access for this technology through other appliance OEMs that want basically our technology, because this market is hyper competitive. You're in the same showrooms as your arch rival all the time, and people are like going between them with their like interior architect being like this or this. These guys see that there's an opportunity and that the cost structure works for our technology, that they're like, can we put this in our products too? And we're doing that right now. But what this means effectively is you go from like, let's call it low tens of thousands of units you can sell as like an individual appliance brand selling like various sizes of stoves, to this actually gets you to the millions of units of this future tech stack in relatively large format products and again, very high volumes. This means that there is now domestic demand for these technologies outside of the EV space, because like drones are not everyone needs a drone, but like everyone has a stove. And there's like 55 million appliances sold every year in the United States. And if we can
55 million.
If we can, and I think that's major appliances. So if you talk about like tabletop gadgets, we're probably in the hundreds of millions. So if you go look at that, you're like, okay, that's a giant.
That's just us,
and that's just us, and it's a giant market. And people spend a ton of money, and the margin profile on these is actually quite good in terms of like you're getting a mostly hollow air in a box, basically. So there's actually a lot of, you can put new technologies in them and make it work as long as that exists. But effectively, what this means is there's now this source of demand for all these technologies that China's better than us at in the United States, and at a price point where we can actually make it cost effectively here as well.
And then so once you're making like all the appliances for everybody, and also controlling the grid and other fun little stuff like that, after you're doing that, then you become like the BYD for all these other companies using the electric tech stack.
Yep.
These other people want to say, you know what, we're going to make a better leaf blower or whatever.
We got to ask to make some pretty cool stuff by some pretty cool people.
Right, and then Impulse or a company spun out of Impulse that like makes things basically becomes the facilitator of this electric tech stack for all the other companies that are going to hop on this and use this to replace every single physical object in this room and outside this room.
Exactly. And I think that the big thing is like you kind of start as like an NVIDIA where you're like, hey, I want to power every next gen device. So like every device with a power cord, we can get this tech stack into. And then also it's like they're also participating as part of the grid in a bidirectional way. But then the second phase is, well, you can start as NVIDIA, then you start vertically integrating your supply chain, and then you become something closer to BYD, where BYD, you can buy cars from them that are fully buttoned up. But I could go there as let's say I had $100 million I want to burn. I want to build like, if you've ever watched that Simpsons episode where Homer designs a car, if you wanted to ship the Homer Simpson car, you could go to BYD and say, make me this, with like literally a screenshot from that episode, and you would get the Homer Simpson car delivered to you in like 2 years.
Yeah.
Like they would design and build it for you.
It's like prompting 03. It's like
Yeah.
You know, hi, I would like a car. BYD's like, all right.
Insert money, done.
You know, and then
by the way, you'll have a factory line that can produce like 100K of them a year. Yes. Of the Homer Simpson car, because they know how to do that. And then
and if you end up not wanting 100,000 Homer Simpson cars, the Chinese government eats the loss.
Or they'll retool it for Chinese market.
They'll retool it for something else. All right. Anyway, that's about all we got for y'all today. We don't do questions here, do we? We're not a Q&A kind of thing, are we?
You can ask questions.
Yeah. Why don't we have Q&A? Yeah.
You didn't answer the rare earth question.
Oh, rare earths. I mean, it's. It's one of the polluting things.
Basically refining metals is like is it from the ground? They're in the ground here.
They're in the ground everywhere.
Oh yeah.
They're not rare. It's just made up.
It's someone was stupid and named them rare earths.
A silly British person many years ago. They're not rare. You can mine them anywhere. It's just we have to build a factory to process them.
Yeah, so the reason we started with stoves was it's the only kitchen appliance where the fuel source is the user experience. So it's like if you can basically like redefine the way it's powered, you actually redefine the product in some key fundamental ways. So that was like the reason we did it. But like we've been asked to do everything from grills to refrigerators to heat pumps to you name it. So
and your heat pump replaces both your heater and your air conditioner.
And a big thing we've realized was basically like it is actually really hard to get market access for a bunch of different appliances. Like appliances are sold through kind of like channel relationships that are really tricky. And like it's almost like car dealerships. So like the big innovation we've had over the past 6 to 12 months is like unlocking how to access those for kind of a diversified product portfolio that might sell in different ways across their respective.
What's one thing outside the appliance space that could be amenable to this tech stack?
I mean, you could put a battery in rack in the data center to basically like peak shave like GPUs during training runs when they're like they spend a lot of power to actually compute, and then they have to share their results with the adjacent racks. Yes. So like that's an example of that. Machining is a good example. Like when it's actually touching the metal, it's drawing a ton of power. Huh. But then when it's like moving around, it's not.
We give out billion-dollar business ideas for free. All right, go for it.
So you said that for us to have more hardware founders, you have to remove some of the barriers so that we don't only have one crazy Goblin and maybe a few other people that can build awesome hardware companies. But then you also said that the Trump administration is like kind of going against this EV push. So like, what is the path?
Well, yeah. So I mean, I would say this as a consumer electronics founder, the current tariff situation is just like where Trump just shakes an 8-ball, and then if he gets called like a taco or whatever the meme is, then he gets mad and like maybe the tariffs are back. So like the current ethereal nature of the tariff situation is not necessarily conducive to business, as putting my business bro hat on. But the big thing is like if I was to describe problems in the space, it's like the fact that like, hey, if I wanted to actually assemble my product in San Francisco, what would be the first thing that would cause a problem? And it's like probably getting permits and then finding people who'd want to work in a manufacturing job in San Francisco because they're like, this is super expensive and I can't afford to live here, would be the immediate response. Oh, and then certification, actually. So this is the other piece. When you build an appliance, you got to get all this certification, and it's like down to the local government level. Like local government NIMBYs are coming for your cool appliances. And
Okay. Anyway,
that's a topic for another. That would be an entire panel, but Lynn would probably be better than me.
Did one other person have a question? Yep.
I was going to ask about the supply chain complexity. The claim being like actually supply chains are getting simpler because it's all just battery, motor, and some chips. It seems like stuff is getting more complicated. Like, couldn't you have said before everything is just like some plastic bits and some metal bits and like maybe a chip? But like, I don't know. Is it really the case that supply chains are getting simpler?
I don't think supply chains are going to simplify.
I asked the same question when we were driving down in the car, by the way.
Yeah, so it's interesting. It's like the aperture of the types of technologies you need to do has reduced. I think is probably the right way to put it. Where it's like, and Noah asked me this when we were driving up here. Was like, are lithium-ion batteries for drones the same as lithium-ion batteries for cars? And like, is that a retoolable thing where you go to the same factory? Typically, no. And because it's just a different format cell, the pack tooling's different. Like, there is specialization in this market, even if you're using kind of the same foundational technologies. And then the other piece of it is a big problem in the U.S. is like there's just not enough of an ecosystem that it's not competitive. Like a big problem in the U.S. is like, hey, I want to get someone to build something for me. I try to get a stamped piece of sheet metal to like adapt our stove for like a couple other sizes. It was like we quoted $700 from some vendor, and it was crazy. China was $200. So it's like, even if like the most ridiculous version of the tariffs was passed, it'd still be cheaper to do it in China. We got the samples back faster. Like, it's also just having these sub-suppliers that are willing to work with you is such a huge, huge thing. And in China, they're like, yes, can do. US is like, well, we have a relationship with Lockheed Martin going back 40 years. Why do I need to talk to you, Mr. SpaceX? And like, by the way, that'll be $1 trillion per Starlink satellite for this little camera that looks at the stars.
Okay, so that is an in-depth answer. Let me give you a simple answer to your question, which is that supply chains are getting more complex within a product line and less fragmented, fragmented, let's say, or differentiated, less fragmented or differentiated across different classes of products.
This is why BYD can make every single device you've ever seen. Like, their showroom shows literally like, it's like everything minus military equipment.
But the supply chain to make each one of those devices is hellaciously complex. It's just the same kind of supply chain. So that's the answer.
Yeah, so I've toured
within versus across.
So I've toured at BYD a GPU. They made a factory that made GPU like graphics cards, a cars, stationary battery packs. I didn't get to see their DJI line, but I wanted to see that at some point. Like they make e-scooters. Like it's kind of just this crazy thing. And then you look at what's actually in all these products, and it ends up being largely the same stuff. Yeah.
It's the same 5 things. Interestingly enough, to go on a slight tangent, that idea was originally pioneered by Panasonic and Sony, and they decided to make every single thing in consumer electronics, which included lots of appliances like rice cookers and whatnot. They decided to make everything because everything was kind of the same tech stack back then. But the thing is, because we didn't have amazing batteries and amazing magnets like we do now, and amazing power electronics.
You got IBO, not Tesla.
Yeah, the set of things that, like, when you said Panasonic makes everything in like 1992, everything was a much smaller universe of things. Now that has taken over like cars and aviation and many things beyond whatever Panasonic was doing back then. All right, one more question? One more question? All right, yep, guy back there.
Yeah, so it seems like we don't produce magnetic steel really at any quantity, which is also a problem for producing our own drone swarms as well, because you need that for the motors. And so I think my sense though is if every appliance gets a battery, then we may need to lean less on our transformers. But that's maybe me talking my own book.
Also, you may also be asking about military options right there, and I think the answer to that is lasers. Zappy.
Yeah, and actually that's the big thing.
Pew, pew, pew.
Lasers are also part of this technology stack, because if you can put a like megawatt pulse capable battery in military vehicles, you can put a megawatt class laser on that vehicle. and efficiency with efficiency conversion or whatever. But you can put a laser that can take out reasonably sized aircraft that'll run just straight off of a Tesla
Or
Model
we'll
S
just shoot
battery.
1 million pulses and take out 1,000
all the drones.
drones.
Yeah. You will be limited by the spinning speed. Actually, you won't actually. It'll actually just work.
Sam is doing engineering in his head on stage. Anyway, all right. Well, thanks very much. Yeah.
Econ 102 is a podcast from Turpentine, the network behind Moment of Zen, In the Arena, The Cognitive Revolution, and more. If you like what you hear, subscribe and leave us a review in the App Store. You can keep up with both of our Substacks for written analysis of the topics we cover in the show at noahopinion.substack.com and erictornberg.substack.com. Thanks for listening.